Hello, I'm Dr. Jason Rose, and I'm a chemistry teacher here in Sunnyvale, California. I've been teaching AP Chemistry for 11 years, and my students typically do very well on the test. I think our average after about 75, 85 students is 4.8. So the kids do very well, and I've learned an awful lot about how to prepare kids for the chemistry test. So I'd like to be able to share some of that insight with you. The main goal of this entire lecture series is to help you review the critical points and concepts in this course, as well as to give you some advice about solving problems and trying to figure out what the AP examiners are up to. All right? There are very particular kinds of answers they're looking for, and sometimes trying to figure out what those are is a little disturbing. So what I'm going to do is provide you with some insight into how they grade the test. I was a grader last year, and I learned an awful lot about the kinds of things the students say that they think are answers and what the College Board actually thinks are answers. So hopefully I'll be able to give you a little bit of insight into that as we go through this series. There's another series attached to this one which specifically focuses on laboratory experiments and descriptive chemistry. And this is something that a lot of students have not had a lot of experience with, at least that's the way it looks from looking over the last few years' exams. So the goal of these is to provide you some experience about here's what a lab looks like, here's how you do it, here's how you analyze it, and here are some of the problems that can happen. So if you've had limited laboratory experience or you really haven't had a chance to have a lot of hands-on time in the chem lab, it's a great series for you. Hopefully it'll also provide you with a better sense of the kinds of things that chemicals can do so that you can work on the descriptive chemistry section of the test with a lot more confidence. 2 tubes. In fact, I think they use that now when you're doing blood donation as a sterilizing agent because halogens do a really great job of killing microorganisms, which is one of the reasons you have them in your hot tub, by the way, and the swimming pool and just about everywhere else. And if any of you are swimmers, you know what kind of a wonderful thing chlorine does to your hair, right? It's a really good oxidizing agent. So we're going to take our last 2 corks, and we're going to cork these up and give them a good shake. And what that ought to do is push the iodine fairly convincingly into the nonpolar layer, so you can see a really nice pink color there. And we'll do the same thing in the other tube to get it ready for this reaction. Okay, there we go. Again, nice pink color. I guess you would call that fuchsia or something. All right, so we're going to add sodium chloride to the first tube, and we're going to add sodium bromide to the second tube. So here's a sodium chloride solution. Now, if you remember, chloride doesn't get oxidized by bromine very well, and chances are it's not going to get oxidized by iodine very well either. But like I said, you do the whole experiment just so you can say you have all the data. And in case something goes wrong or gets very strange, then you probably can predict, oh yeah, there's something wrong with that, I need to go back and check it. As long as you're careful about labeling your tubes and you know what you're mixing, it's really very hard to make mistakes with this experiment. So we're going to shake this up. Chloride ions are pretty much ignoring the presence of iodine, and so the iodine really doesn't get any satisfaction. It doesn't take any electrons away. So we're left with the same purple layer we started with at the top. So let's try that with bromide. All right, there's a little bit of Br minus. I'm just going to put that in this tube. It's always a really good idea to close the caps on everything, just in case you trip and knock everything over, very little spills. All right, so here's the Br minus. And as you can see, Br minus isn't particularly interested in giving up its electrons either. All right, so there's really no change in the color of the layer there. And that would indicate that Br minus is not capable of giving up its electrons to iodine. So those are all the halogens. Now, while we've been doing all this, my metals have been reacting, so let's take a look at those and see if we can find anything that's changed. So anyway, that's the series. Hopefully you will find it useful, and you'll enjoy watching it as you study for your AP Chemistry test. Thanks very much. Hope to see you soon.